Hello and welcome to the program. I'm your host, Neil Howard, here on Health Professional Radio. Thank you so much for joining us for another segment. In this segment, we're going to be having a conversation with Dr. Emily Paul. Now, Dr. Paul is a molecular biologist with a specialty in genetics and product director for SOPHiA Genetics. She's joining us to talk about processing thousands of genomic profiles for diseases such as cancer and inherited disorders, where combining genomic and phenotypic information is vital to support discoveries, treatment decisions, and drug development efforts. Welcome to Health Professional Radio, Dr. Emily Paul. Thank you.
Thank you, Neil, for having me today.
Well, of course, I mentioned your role at SOPHiA Genetics. Give us a little bit of insight into who you are.
Sure, happy to do so. As you said, I'm a molecular biologist with a specialty in genetics. And what that really means is I've had the great privilege to do some academic research, but turned it to helping folks adopt genetic testing in a lot of different ways. And that started with my role at SOPHiA, where I worked as our field application scientist and became the director of the team in the Americas, and had the chance and opportunity to work with some really diverse and incredibly talented labs at different academic medical institutions throughout the country. And really that was an opening experience to appreciate the clinical workflow that a lot of labs have to adopt to be confident in the results they're producing for a precision medicine approach. And with that experience that I've gained, I've had the opportunity to shift into the product director for our platform, to taking both my experience and my interactions with all of our customers to be able to say what kind of platform we need to evolve. And when I talk about platforms, I'm specifically talking about genomics platforms. So ways and tools that we use to interpret genomic data and profiles of, as you noted, oncology patients, as well as inherited and rare disease patients, and how we can best facilitate that interpretation.
So I would assume that this genomic testing, this processing, as I said, thousands of genomic profiles for these types of diseases is absolutely vital in not making mistakes. I guess not treating one patient as if their treatment is the cure-all for everyone with the same disease.
Well, I think that's a great point, Neil, because we see so many profiles and we are starting to understand it's not just this disease umbrella. And I'll use cancer simply because it's a very easily dissectable one, but this applies to other diseases. But when we see all of these profiles, we know it's not just cancer. We know it's lung cancer. We know it's colon cancer, breast cancer. But now we can start to fragment these to appropriately get treatment to individuals so that either they get the more aggressive treatment that may be required for the types of mutations that are present in their disease, or they're not getting a treatment that's more aggressive than they need. And oftentimes with that, we see a really painful treatment that may be overkill. Let's avoid that if we can, right? Give folks the best shot at being able to beat cancer, or to put it into remission, we should say, and really be able to narrow that down. The same for inherited diseases. We want to be able to look at these types of mutations and understand these profiles. But when it comes to rare diseases, you need to be able to collect those thousands, tens of thousands. In fact, we have over 1 million genomic profiles in the platform, with approximately 20,000 new genomic profiles coming in every month from different customer labs in 80 countries around the globe. So we're really seeing a diverse set of data to better appreciate where these rare diseases come from, to understand what the outcome may be. And that also links back to the phenotypic information that you mentioned. We need to be able to understand that. And I think there's a huge benefit both to the oncology and to the inherited and rare disease field with that.
Is this a very prominent idea in the industry, or is this something, this approach relatively new? And do you get pushback in favor of the standard or historical go-to treatments for these diseases?
Sure. No, that's another good question, because when we see folks adopting technology, we know there is a burden of proof to show that it is a better and more efficient way to run the testing. We help labs adopt that through our setup programs. Of course, we can't do a lab's validation, but we can support and enable them to do their own through different mechanisms that we have. And we do get some questions, but I think that's part of our job, is to educate people on the benefits, to make sure they see this. I mentioned my former life as an academic. It's not necessarily a new technology there, but as we're coming into different spaces we're realizing some folks still haven't adopted NGS as a mechanism of precision medicine. As you mentioned, there are some oldies but goodies out there that folks rely on. We want to help them be more efficient in their process. So there is that education component, and I think it's well worthwhile. And we're really seeing a general shift in the field. It's not, is NGS okay? It is NGS okay for me, and am I ready to adopt it? And that's okay to ask that question. It requires resources, it requires training, it requires information, and that's what we hope to do through the platform and through the global community that we foster.
I think it's safe to assume that researchers have a certain mindset when it comes to gathering and analyzing data, as do healthcare providers. How can you get the two mindsets together?
That's great. I saw that as I made that sort of switch into a more clinical sphere from a more research-oriented sphere, and that's why I chuckled, because it is a different mindset, but they're so close together. They're so close together, and it's the regulations that are there, because there's a curiosity, there's a willingness to do better for those that they serve, whether it's through a research situation or through a clinical practice. Folks are trying to do the best for what they can. And it's just a matter of making sure different I's are dotted and different T's are crossed on the paperwork to make sure that we're all doing this in the safest and most appropriate way possible.
Now, the AI doesn't really care about the mindset of either or. It just crunches the data and presents it. What about the sharing of the same types of data, among these different mindsets for the optimum outcome for the patient?
Sure. So our AI does a lot of work in understanding the variants that are identified, in understanding how annotations of these variants are appropriate. But there's a distinct difference in the ways these are generated. Largely, we see a lot of clinical data going through the platform. So by and large, the pool in the community is a clinical pool and community. We do research projects, but we sort of separate some of those. And when I say research that we separate, those are pure research. Clinical research still goes into that same pool because it's executed with the same I's and T's, as I mentioned, and it really keeps it in alignment with each other. The generation of the data is the important part, and we want to be able to be confident in what we're providing.
What about the tracking of these patients? Obviously, with the AI is integral in making these decisions for treatment. But what about tracking some of the drug reactions, making sure that, this patient reacted this way on this drug. Let's take a look at it for the next month, or let's take a look at it for the hundreds of other patients who may be on this same medication.
Well, so that's actually a direction we're going in at the moment, which is this multimodality. And we're building a longitudinal tracking information so that we could look at a grouping of individuals to better understand what is possible. And we have a new collaboration with GE Healthcare that was announced at the end of last year that we're very excited about, so that we could start to bring in multiple fields of information. So we're looking to imaging or medical history, right? That's the first omics. If we're talking large sets of data, medical history is the first patient omic. And then we need to go into further things as we see them most relevant. Maybe that's proteomics to cover things like drug reactions. Maybe that's transcriptomics to see different expressions. And so we're bringing these things together to take a more comprehensive and large picture view for precision medicine so that we tackle the true individual as opposed to just their genomic profile.
Well, Dr. Paul, please give us a website where we can learn more about your company and the technologies that you're developing and offering there.
Happy to. That's going to be SOPHiA
Okay, and that's SOPHiA GENETICS.com, correct?
Absolutely right. That's SOPHiA is the goddess of knowledge, and we like to call on her so that we can make sure we're we're providing the best data possible.
Well, I appreciate you giving us some of your time this morning, Dr. Paul. Thank you so much for being here on Health Professional Radio.
Thank you, Neil.
You've been listening to Health Professional Radio. I'm your host, Neil Howard, in conversation with Dr. Emily Paul. Audio copies of this program are available at hpr.fm and healthprofessionalradio.com.au. You can also subscribe to the podcast on iTunes, listen in, download at SoundCloud, and be sure and subscribe to our YouTube channel at youtube.com, Health Professional Radio.